Is the mic fine? Yeah.
It is. I believe so. And let's play that cool video to get started.
Sounds good.
All right. Well, welcome back to episode 7 of our workshops that we're doing, contribution workshops. Tonight we're going to go over sort of a custom image with Leap Micro 6. It's in alpha stage right now, doing a spin and our image spins and like building custom packages for those images. So Lubash is going to take it away. I'll go ahead and narrate and monitor different things. And please ask questions if you want. And
Absolutely.
the link you see down there is could get you to some articles that we have published about the contribution workshop, and feel free to participate and sign up for one if you would like to join us. So take it away, Lubash.
Yep. Let me just destroy everything that I have been working over past few minutes. So we start with a clean sheet. So hey, everybody, I'm super happy to have you here. And let me actually even describe or explain why would anybody want to build custom image. So let's say that you would like to install Leap Micro Tumbleweed in your company, but maybe you would like to actually pre-select different packages. Maybe you want to have your custom repository instead of the default one. Maybe you want to make sure that Google Chrome is installed by default, whatever your company needs, right? And for that, well, you have two options. You either install Leap and then maybe through some scripts afterward or from some software you actually deploy changes, or maybe you want to actually install it right away the way how you want it, right? We have also technologies like AutoYast, but creating very simple image that contains everything you need and just write it to the disk is probably the easiest option. Plus, you can do it completely through the UI of OBS. So let's have a look. Basically, what we want to achieve here is having an image of Leap Micro 6.0, which will have one extra package, which is normally not installed. And that package will define a new repository on the system, okay? So you can actually install like more custom software if you want to, not just from the distribution. Let me screen share. We will be mostly using OBS UI, not really terminal, which I think is great news for everyone. So you want to go to build-openSUSE.org. If you go to build-openSUSE.org, you will basically get to the same screen, okay, here. And thanks to Fabian, because he created an image or a template for Leap Micro 6.0, you can just literally click on the new image. Supposingly that you are logged in and everything, you can just click on new image. And if you scroll very down, you will choose Leap Micro 6.0. For those who don't know what Leap Micro is, it's not your traditional distribution. It doesn't have desktop. It's literally server-oriented. Specifically, it's designed to run containers. It's immutable system, okay? It's not your classical desktop distribution, but you could do it with anything else. You can do it with SLES, you can do it with Leap. Since Leap Micro is very small, it's best for the demo. Image is super small, about 1 gig. So just click on it. I will call it Demo Micro. You could keep the Leap Micro, I guess, but we will call it Demo Micro. Just click on Create Appliance. That's literally it. Don't mind the error. That's the limitation of the UI, editor. And as we clicked, created like a new subproject in our home project, we are already building the distribution or the distribution image, okay? It's already happening, which is awesome. And you could say we are done, but like we didn't really modify the image in any way. So that's what we would like to do now. So for this change, as I mentioned, we will actually add new package, which will contain the repository definition. So I already prepped the work. We will be forking openSUSE repos package, and we will add like demo sub package in there, which has the repo. So normally you could actually just go maybe to develop project or to the distribution where you want to fork it from. Doesn't matter. Let's do it, for example, from base project. You know that it will contain all the latest changes, and you just click on branch package, okay? And I already did it, so I will not do it. But you could just click on branch, and it would create, branch of this package in your project. So I will already go there because I've done it. It already contains some changes. As you see, I've added demo repository definition. It's basically this little XML file, which points to the project where we, where we will be actually building any new custom packages, and where we build also the distribution image. So very easy. And if you are interested and in the spec, we basically have that file as a source. You have a package, which then installs the repo index, and that's it. Okay, this is how we define repositories in Leap Micro 6.0. Good. So we have a fork, but we need to get it here. So I will, for this one use case, use OSC in command line, and we would use OSC copy pack. I believe I already have OSC copy pack. I have it prepared. So OSC copy pack, wherever you copy it from, I have my own branch. You could maybe be copying it from openSUSE factory. So since I've done changes in my branch, I will copy it from my branch. And the destination will be, and doesn't have to be, you can build it in separate projects, but for simplification, we'll build everything, including custom images in this single one. You actually want to copy it here, okay, into this project. So this is what you would copy, and this is what matches here. So I would just hit enter, OSC copy pack. I hope it's readable. Done. And if I refresh, I should see a package. But it's not building. So how do we make it build? This project, if you create a template of image, is building images. And in order to build repositories, you have to configure new, in order to build RPMs, you have to configure new repositories. Again, we could do it through clicking here, or just select through checkboxes in repositories, which I think is easier for, especially if you're a newcomer. We can add from distribution or a project. I suggest that we would build it on top of Leap Micro 6.0. So I will just look for Leap Micro 6.0. Correct. And for RPMs, we use standard. Containers for containers, images for images, standard. That's the typical notation. And we can call it standard as well. Let's not build for, not for S390X. Let's keep it on 64-bit Intel. And if you look, we should be building in a few seconds that openSUSE repos. Yeah, it's building. This should take literally a few seconds. So what we have is we have a clean copy of the Leap Micro image, which is called demo micro, but it's the same as of now. And aside from that image, we actually built a forked package, of openSUSE repos, which is normally part of the distribution, but we've done the change that we've added demo subpackage, which will define repository, which points to this project, because what you want to do if you create your own distribution or your image, you really want to be able to provide your software changes, right? Not just the default distribution ones. And this is the way how you can do it. So basically the repo will consume any sort of RPMs, which will be published in this repository, which goes to publishing. So if I would just build the package and I wouldn't publish it, it wouldn't be really downloadable from any sort of URL from this project. So we want to publish it, and this can be also done in repositories. And I will show you how it looks if you don't do the publish. So in case that you hit that issue, you will actually see how it, what sort of issues you are getting. So just by looking, I suppose we should be almost done here. Okay, it's still installing the environment, but we are not doing anything than just putting few files together. So we are not building anything complex here. Should be quite quick. Paused. Okay. Let's see. By the way, we don't have to wait for the entire image build. I've already downloaded the image a few minutes ago from the previous setup of this project. So, wait a second. Okay, now we are done. Perfect. So we have our package. It's built. If you actually go here, you can see that we've generated the demo subpackage, which is what is not present in Leap Micro itself. So if you would go, for example, to literally openSUSE repos, and we would find the one from Leap Micro, you will see the demo subpackages in there, right? We just built Leap Micro 1. And here we have Leap Micro demo, which is extra. Cool. So let's make sure that it's part of the image. How do we make it? So as I mentioned already, we built the image, but we didn't really publish it. So, if you can't really go to download the repository, it's not here. So now you go to repositories. And here we have publish flag, right? So if you want to also have an easy option how to download image, you want to publish also the image. And this is for RPMs. We want to do both, I suppose. So we can do just all and enable. You can see a little icon that will pop up. And yeah, it's published, it's delivered. So here we finally have the repository. And this is basically the repository that you want to enable on the installed system, or it will be part of the image which will be deployed on your machine. And any sort of thing that you build in this repository, if I would now copy back Firefox, well, Firefox is bad example for micro, but I don't know, PyTorch or anything, it would just be available to the image. And now with just one edit of the kiwi file, which is the file that defines the content of the image, the other interesting would be config.sh, where you could do any definition of systemd services for the image. It's literally a bash script, but we'll be adding image to keep it simple. So we just go for the kiwi file. As I mentioned, the openSUSE repos is already on the image because we define default repositories like that, but we didn't make available the demo subpackage, right? And the demo subpackage, if you remember, was called repos sleep micro, right? And we are interested in this one. Let me copy paste it so we don't have any mistake. Sleep micro demo, right? Yeah. Oh, that's from the standard. Sorry. Let's focus on this one, which was the one with the demo. Yeah, the micro demo. And we click save and leave micro demo to our self-install image. Self-install image, what does it mean? Well, basically we built like, if I will simplify it, something like UCal image, and the self-install image is little tiny wizard with ugly GUI that takes the image and writes it to the disk, right? So it basically takes any content of the image that you can modify, for example, through this config.sh. If you would like to, you could maybe add like Flatpak repository here, whatever you want, it will be on the image, and then, the self-install would actually, that wizard would deploy it on your disk. So, and you can see that it has failed because the package is not available to the image. So we have it built separately. We have it now defined in the image kiwi file, but how do we make it available in the process of building the image? Well, that's done through the inheritance. So if I go to the project here itself and I click on meta, you need to make sure that packages that are built in the standard repository are available to anything that you built in the images repository, okay? So, and that can be done easily. So we will just add the standard repository here. Be careful, it's not the images that we build it on top of, it's the name of your project, okay? So we want to have and we've called the repository standard, right? So it should be standard. Add our standard repository, your repository. Okay. Now you can see it will trigger rebuild instantly or within a few seconds. And finally, we actually, and we made it now available. So these are the steps that you need to make sure that happens. So the change that you've done can actually get to the image, okay? If you would like to use maybe image from another project, you don't have to fork it necessarily. You may want to add something like, I don't know, a repository related to AI. It could be PyTorch repository. You may just want to add it to the meta, and then it's available, and then just tweak the kiwi file, add any packages that you want. You could say, well, the kiwi file is quite long, so what section? That usually our kiwi file is quite complex because we have multiple flavors, but I've chosen the openSUSE repos section because that's available on basically any flavor. It's for all flavors, which makes it easy. you could edit, for example, only for ARM images. There are multiple sections like that. I think Leap is a little bit cleaner than this one, but yeah. We are building only one flavor in our image template. You could define more with multiple, but they're basically disabled. This is what the file is for, just to enable or disable building of flavors which may be defining in the QA image, or in RPM. But this is it. So okay, so now it's building. I will not take too much of your time because again, I've done this exercise before this meeting, and I already downloaded the image. So we can just go ahead and try how it looks like. Let me destroy it so you can choose the process. I will just delete it. Yeah, let's not delete the image itself. We will do new, local, I think that, yeah, we want the latest one, 3.2. And we don't have Leap Micro, but we have Sleep Micro defined. It's the same. Leap Micro is literally a rebranded Sleep Micro. And this is fine. I think that for our demo, we don't need really that much. And I will call it Demo Micro because it's our custom distribution, if you want to call it like that. Yeah. And let me just resize it so you can see it. View resize, not resize to VM. Scale display always. Good. So we'll be installing it. Again, this is like the most, well, actually, this is the only way how to install Micro 6.0 nowadays. It's self-install. It literally just dumps the image to the drive, extends it to the size of the disk. That's it. Okay. And you can see it's pretty fast. Like this is literally, we are like 50% done right now. And this is seconds. It's also the fact that we have actually a NVMe disk on the workstation, but yeah, still pretty fast. And basically, if we succeeded, what happens is that if you log in for the first time to the image, you should have openSUSE repos demo defined, okay? And as it boots, it's actually, let me show the content of the package. It's literally, oh, sorry. It's just this one file, which defines the repository path. And we run like zipper add service on it in the spec, and that's it. Good. So here we are booting. We don't have combustion or ignition mounted to the VM, so it failed. That's expected. By the way, check on that on openSUSE Wiki. This is really cool way how to configure your image. It's alternative to do changes in config.sh or so. You can just have the changes on the USB drive in a script and make sure that they are performed on the first boot. Yes. I will use test as a password. And we are done. That was the entire installation of the system, basically, under, I don't know, 2 minutes or so. So, and yeah, moment of truth. If I do openSUSE repos, we should have demo there as well. And we have openSUSE repos Leap Micro and openSUSE repos Leap Micro demo. So we are basically done. Let's see if I did any packaging issue. This is the funny part of the live demos. Accept new key. Yeah, seems like everything succeeded. And that's basically it. Does anybody have any questions?
So yeah, Lubosh, there's a couple questions here. Yeah. I'm going to put it on the screen. And I think we kind of know this, but you could read it there.
Yeah, so I see. It's like Aeon. Yes. So right, like both Leap Micro and Aeon are based on technology that was developed as part of MicroOS. And MicroOS server would be basically a rolling version of Leap Micro, if I can call it like that. Aeon is basically MicroOS server plus tweaks for GNOME desktop, right? That Richard makes. So the base is the same, it's transactional update based, but Leap Micro is just the server part. It's really intended for server deployments or container hosts or edge, anywhere where you want transactional update system as small as possible with automatic updates, rollbacks, and all the stuff like that. It's not rolling release. Keep in mind that Leap Micro is released every half a year, okay? Typically April and October, we have new releases and we support it over 2 releases. So when 6.0 is out, the last one, the release was 5.5, so 5.4 would be EOL. But 6.1, 5.5 would be EOL, and you would have to upgrade, and so on. Does that answer the question about like Aeon?
I think so. I mean, it was kind of filled in.
Yeah. By the way, guys, so you can install Leap. Well, you could in the past Leap as a transactional update server, but like we kind of thought that the technology developed in MicroOS is like superior to whatever was like in the profile transactional update server profile for a Leap. So we would say everybody who wants to use transactional update server like system should go and he doesn't want rolling release, then he would use MicroOS, right? If you don't want rolling release, you want transactional updates, you want server, you go for Leap Micro or Sleep Micro, right? If you want to pay for support. I will use it. Yeah.
I'm just going to read out the other one. This is sort of the first
Kubernetes, absolutely. Yeah, K3S, so on.
No. There's a question higher than that. So,
okay.
Is it possible to use OSC CLI in the meeting to create new application at the demo? I think it's kind of hard because
no. Like the template is basically doing one thing. It literally creates new project within your home directory, and it really runs OSC copy pack, right, of that package from the template repository into yours. So you could do it with OSC copy pack from let me show you. So the answer is yes, but the nice thing about the template is that actually, you have properly set up repositories and everything that you could have missed with OSC copy pack, and if you would create a repository or the project by yourself, right? So if you see it actually links to the Leap Micro, so you know that it runs copy pack and creates a link against this one. So you could literally copy it from this repository with OSC copy pack to your home project, for example. But then you have to define that images repository yourself. I think it's much easier if you actually use this template system and you make it do the work. We've done it in the past. If you, for example, don't like the path and you would like to do it by yourself, feel free to. You just need to basically reproduce this setup. Just make sure that you are building with images. You have the proper repository set. That's all the things that the template mechanism does for yourself. Okay, so you save yourself some time and some trouble. Okay, does it answer the question?
I believe so. I mean, we could see a comment later, but the next one was the Kubernetes one. So is there
absolutely.
a way to disable automatic restart of MicroOS, for example?
It's
restarts it's required.
This is all system-based services. We have like the automatic updater service. You just disable it. Like you can do it through Cockpit, for example. Or if you would use ignition combustion, you could do it there. Or if you build custom image, right, you can actually override it in the config sh, because that I think defines also systemd presets for you. Easy.
Cool.
And so you can do that. You can literally do anything with the config sh script. Let me just make sure that people know which one I mean. I think that I've showed it, but share screen. So you go to your project, right? You click the demo image. I think you would go to something like config sh, or you have like package systemd presets, which you could fork and change the presets, for example. I believe we are using systemd presets SMO, like Sleep Micro. Okay. Yeah, you could do like one-off services. You could rename something that was defined by other package, or as I mentioned, for the preset packages, which probably has the preset for the auto updates and auto restarts that you are mentioning, right? But you could do it here as well. But consider this like last resort. This is like, this allows you to do pretty much anything.
And then Gertian has a question. Could one use pattern XYZ or XYZ packages that contain the...
Absolutely.
needed software. Yeah.
So what you could do, and I can show how to do it, you can basically copy back. So let's say that you want to add a new pattern, right, to your image. You have two options. Well, it has to be built somewhere, right, as a package. So in Leap Micro itself, we do it as part of, and let me show you. We do it as part of these 00 packages. So if I would go back and, well, actually, let me show it to you on openSUSE Leap Micro. Here. Patterns are usually defined in 00 packages, right? And we actually inherit the ones from Alp. So if you go to group, you can actually see that they are sort of, they are sort of all inherited here, but they are actual packages, right? So you could create new pattern for sure. You could make it like available in one of the groups. You could add it technically to the image itself, right? Via the Kiwi file. But make sure that you actually add the repository which contains the packages referenced. Sorry, you have wrong project here. You actually add the repository that contains packages pointed to from these patterns, in either standard or images repository. Because like if you reference, hey, I want like Firefox from your pattern, but there is no repository defined that would actually contain Firefox, then it will not work, right? So always make sure that you have the repository, or you fork the package and then it builds in your repository, and we already have it here. But then maybe you need to make sure the dependencies are satisfied, copy them, or again, add some repository that has the dependencies. So that's your fight, like how you want to do it. But make sure that you have patterns and also access to packages which you are referencing. Does that help? Mm-hmm.
Yeah, I think so. I think we're good.
Cool.
So I'm just going to provide just a little bit of information. So the next
wait a second. We've missed from Matos one question about the email. If you could get email that the restart is required. So systemd has email notification service as part of Leap Micro 6.0. Sleep Micro 6.0, we will actually have defined that in documentation, how to easily set it up with like a nice snippet that you can just copy paste. That was something that I really wanted to do. I think it should be in Juice first boot, like configuration, where to send notifications. That's like step number 2, I guess. Right now it will be in docs. So go through, I think it will be the installation guide. We really wanted to make sure that the user is aware, like if something's broken, like the update didn't work out, that he actually gets email, like to your Gmail, whatever. And I hope that it will be soon the first boot. In the first boot, the configuration where to send it and your SMTP relay. But right now it's docs, but like we do not really have like service that would tell you need a restart. We have a updates that could be in, but like you would probably get only notification when it fails, not necessarily when it succeeds. You would have to configure the notifier maybe in a different way. We only really document how to actually get notification about failed updates that require your attention. What you can do for automatic restarts, you could set very, very, once a year window, for example, because you can actually set up maintenance window. When can restart happen? And that would be one way. So you would have pretty good control about it, or disable the restarts. But then you have to really figure out how to configure systemd to make sure that even if the service succeeds, that you get an email. But then you will have a difficulty. Imagine that the service succeeds when you run like a transactional update and there is no update, that's still like successful exit, right? Versus update that succeeded, which is also successful exit of the service. I'm not sure if that's easy. The failed update is easy to configure, to send a message. Maybe we could consider it a feature. If you would go to, can I just send it? Go to openSUSE.org, sleep features. You can actually describe, hey, I would like to get a notification when the update happens, and I am supposed to do manual restart if I don't have the automatic updates configured. Oh, I can't send URLs through. Maybe let me skip the HTTPS. Maybe that will work. No, It writes me command has failed to post to openSUSE deck. Can I send you the URL through, I don't know, Telegram?
Yeah, just put it in Slack. Put it in Slack.
Okay, Slack. That works. Interesting.
I can add it. Or
It's actually quite interesting use case. I mean, like you could probably configure like some more advanced monitoring for that, but I think that it should be, that's actually a fair use case.
Sure.
But then I don't see much of difference. Like if you would just disable automatic updates, you would just go and do transactional update something. The power in the system doesn't require really your attention is that it really happens automatically and you are notified only something doesn't work, and you can really tweak maintenance window like on, I don't know, first Sunday of the month or so. The not timer, I think this is notifier. Just look for systemd notification or notifier. And we have like service for updates, right? That's a I think update something, Demon. I can look it up on the micro if you want. Systemctl grep update. Yeah, I mean. Right. It's called the transactional update timer. That's the service name. Interesting. If it's not URL, it works. And make sure to really go through the documentation for Sleep Micro 6. So I think it's in beta. I'm not sure if the beta install guide has it, but the final one, which will be available in May, there we will have actually nice copy paste use case of how to set up the notification for your email. Just keep in mind you will have to use some SMTP server which doesn't have authentication.
All right.
Any public one will be good enough, I guess. Cool. Any further questions? More about how to build your custom image pins and less about Sleep Micro itself. But like, yes, since there are no more questions, we can totally discuss Sleep Micro too. If I were to make a macOS ISO with Tumbleweed base, macOS has Tumbleweed base. Like macOS is literally one of the Tumbleweed images. It just has like read-only root set to true, right? That's how you make immutable image. And then of course, like, config SH is tuned up for it and so on. So it's not the same, but like literally all the packages from Tumbleweed are available to install on the macOS server. So that happens by default. You could also, and we've done it, you can also make Leap image, which is transactional update, like uses the same stuff as macOS. We've done that in the past. I can maybe screen share. But what you said is basically already macOS. There is no difference. Unit. Build, right, openSUSE.org. I think this was for SUSE IT. So if I do something like this, yeah, exactly. Here for example, I think that I've made it part of the live CD openSUSE because we had other live images here, but it was, maybe Doug, if you can copy paste it, because the URL will not work for me. We've had where was it? Live CD openSUSE, and this was called CSB, right? Self-install here. Ooh. Oh, right, we have here this self-install gnome CSB Kiwi, and that was literally image which was done in the macOS fashion, but it was based on Leap, so not Tumbleweed like macOS is. And how you define whether it's immutable or not, like if I simplify it, because we have all of the other configuration with Flatpak enablement, FlatHub enablement, and so on already in there. We are using the config SH from macOS. It's literally root here. DTR FS root is snapshot. yes. And if it's read-only, if you would set it to true, you would essentially have like immutable distribution. And if it's like this, it's standard leap, but like you have the ignominious setup and everything that you know from macOS or Aeon in this case, because this has GUI. This was intended for SUSE employees. So you can see that, it's quite easy. And it will boil down to what repositories are you using. Here we were building it on top of Leap 15.4, and we were using Rancher stable for Rancher desktop and some custom images for SUSE IT. So it was a little bit more advanced BIM, right? Basically, this entire exercise, more or less, is how I personally create Leap micro out of Sleep micro. I also I don't use the template, but I copy pack the image, I rename it, and I remove branding, add packages which override the Sleep branding. It's not that many. It's like 8-10 packages in total to turn Sleep micro and Leap micro, and you can see that you could do that with Leap micro to any of your company distribution that you need, or any sort of appliance image that you need for for your application that you are deploying. It could be built in the image, right? You could just build it next to it, or you provide the repository that contains it, for example, and install it, as part of building. Keep in mind that OBS kind of has a limited access to network during the build, so that would not be possible. You would have to attach the application as source or build it next to it, right? Maybe from binary artifact. But yeah, you can see that yes, this defines the product, and these two are actually generated from the package group, so that's a little bit special. But then we have the image itself. We override branding. We supply custom keys. I define what repositories the distribution should use, and then just structure. And this is the toolbox image for debugging. Something like DistroBox, but literally intended for debugging, so you don't have to reboot your transactional update server every single time, and you have to install like additional debugging tool. Does it help Unit? So literally MicroOS really, if you would check, it's actually built as part of the openSUSE factory, which is where we built Tumbleweed. So it has all the Tumbleweed packages. If you would like to make non-immutable MicroOS-like image, which I guess doesn't make much sense, but if you would like to do it like little something with still Tumbleweed packages, you could just fork the package and just set that root is read-only to false. So this is what you ask for. Cool. I don't think it makes much sense because we have minimal server install of Tumbleweed, which is probably what you want. Yeah, it doesn't have container, I guess, or Podman and stuff installed by default. So not sure if there is matching profile for container host on Tumbleweed installation. Mm-hmm.
So Luboš, I think we probably close it out.
I would do that. I'm happy that I hope it helped you.
So anyway, actually, you brought up DistroBox and Lucas at the openSUSE conference is one of the keynote speakers. So
DistroBox is cool. DistroBox is cool. You should use it. You should use it.
And then the next episode that we have planned is basically going to be packaging updating with style using services in OBS. Don't exactly know when that's going to happen, but probably looking at early May. And we have had to switch a few things around sometimes, but yeah, we'll keep you informed. You can actually get that information on news.opensuse.org. And yeah, if you're interested in Leap Micro, please go ahead and download it there, and you can download other distros that we have on get.opensuse.org.
Exactly. You can fork Tumbleweed. By the way, as we speak, the image build succeeded. I think we can check. It took exactly, yeah, I don't see the time. I guess you would have to have multiple. It was pretty quick. 600 seconds, 10 minutes, including the compression, and compression takes long. Yeah, so we are all done.
Cool. And if you want to join us, we'll probably be in the bar right after this. Feel free to hop in the bar anytime. Sometimes people are there, but just hop in and ask questions, meet the community, and join us and get to meet good people like Lubash and myself. So
Yeah, absolutely. I'll be there. I still have something to drink.
well, thank you, and
See you in the bar.
we'll see you in the bar.